Hello to viewers, welcome to my channel Science to Technology. In today's show, Computer Wednesday, we're going to talk about Z-Wave. So let's dive deep into it. So what exactly is the need? Well, it's the same need as basically all other IoT devices, something that is low power so it can conserve energy. Because be mindful what we are actually doing. What does smart home means? Basically take PLC that runs our factories, our industry, and make them low power, make them low cost, fit them in our house. That's it, nothing more than that. Now these things are designed to be robust, to be absolute. So they have wire connection and they are very power hungry, but benefit is that's how your factories work. So we need same feature set but different logic. The logic is low power, so it can run on battery while being wireless. So that's a painful thing. Then it has to do something that we can do, mesh network. Now these things, PLC network, they are generally star network, meaning every wire feeds to a central point and central point does all the crunching and then it applies the actions. Now mesh network allows you to bypass that. Now why would you want to bypass that? Well, if you have a star network like a Wi-Fi router, each Wi-Fi router can only handle few devices. It will get overwhelmed. It's not designed for that. Now again, there are protocols that allows like Wi-Fi Halo that can handle that, but normal Wi-Fi cannot. Same with Bluetooth. Mesh network allows basically hopping to happen, meaning you can have one device, you can have another device, and data can go yeet somewhere else. So now you can have every device can help the network to become far more streamlined, far more capable, and far more robust. So you get the reliability of something like this while having multiple nodes. So mesh network is a must. That means in protocol level, it has to be redesigned. You cannot just use a normal star protocol and say, okay, now behave like a mesh. It has to handle packets based on that. Self-healing network, this is another requirement, meaning when you are talking about these things have such a good feedback loop, and not to mention there is people 24/7 around them to make sure if something goes down they can take adequate action. In your household, let's say these things are battery powered, not all batteries will run down exactly at the same time. Some would dry out very early, some would last very long time, some might break, things of that nature. So your network should not go down because one thing went oops. In a mesh network that could happen, so you must have a what we call self-healing network, meaning if a few devices goes offline, of course there is an upper limit. You can't have like 50% of devices going down and then network is like I'm good, unless you built it that way. So self-healing within normal tolerance and using non-congested hertz, as in 2.5 gigahertz is awesome. It's used for cordless phone, your microwave, to your Bluetooth, Wi-Fi, every Tom, Dick and Harry. Problem is everybody is using it, so it's very ludicrously noisy environment. So you want something that is not using that same frequency. Now it must have high reliability. All things come here, because be mindful, sometimes you may be connecting to something important like a house lock, you may be connecting to something important like water heaters. So it must require high reliability, not as reliable as these things, but reliable enough. So this is a long list. So Z-Wave was built to take care of this list. So what they did, they went sub-gigahertz in frequency. So they are below 1 gigahertz. Now that allows them to do low power mesh network. Each node can hop from one to another without consuming too much power. Now that started in 1999 and Alliance was formed few years later. Now hey still, have you ever wondered how the heck your TP-Link or D-Link or whatever have you works with every other phone? Well, because there is an association known as Wi-Fi Association whose job it is to basically handle every single company who wants to use that stamp, that Wi-Fi stamp. They have to go to them, get it verified, get it validated, quote unquote. So that requires certain as agency. And same goes with whenever you are building any sort of protocol. Protocol is useless if you are the only one. That becomes a proprietary system. Other companies will not use it. To make sure all these companies agree to single thing, there must be association where everybody can chip in. And of course, you have to pay a lot of money to get into this, pay a lot of money per device in order to get it validated. But benefit would be when customer buys it. Of course, we will be paying high premium for that alliance. But when customer buys it, it just works. So same way like we have Wi-Fi, it just works. Same way Z-Wave Alliance was built very early on just to make sure that every company that is investing into this ecosystem, none of them single-handedly are responsible for everyone else. Everybody else is chipping in, and now everybody can trust everybody else equipment that it will work nicely with each other. Because mesh network, you may also have other brands in your mesh. So if they are not playing nice, it could be a disaster. So for that reason, to maintain compatibility and to reach that is just work. So for this exact reason, this alliance was created, and a high premium was paid by all this brand, which trickles down to you. So what about its topology? Well, its topology is designed to be a bit flexible, so it can scale up to 232 devices. That's huge. That's almost reaching factory level. So it's significant. Now it has a lot of devices. Of course, it will start with controller, then it will have routing, and then it will have slave devices. I have no idea why the heck they have that term, but they have it. And what does this mean? This simply means routers are the hopping points that allows you hopping from one to another, and slave devices are the end devices that does your final thing, either receiving data like a temperature sensor, humidity sensor, things of that nature, input devices, or output devices, where it could be turning on relay, turning off relay, things of that nature. Generally, end devices or devices overall are configured in two categories. One is listening devices, one is non-listening. Listening devices are generally mains power, meaning if you have a light bulb, it may be acting as a listening post. Then you have non-listening one, which generally would be battery powered. So all of your nodes cannot be battery powered. Enough of them have to be AC mains power or router, quote unquote, so you can have a mesh network. Without mesh network, it won't work. And for mesh network, you must have a router, at least 2 or 3. Nowadays, you do not have to worry about it. If you are talking about any equipment that is Z-Wave and connected to mains, 90% of the time it will be a mains powered listening device, meaning it will relay the signal from itself. So you do not have to worry, buy dedicated router. Sometimes it's needed if you have some weird dead spot, that may be desirable, but most of the time you do not have to worry about it. Now, how the heck all of this is so far is normal. So what is unique about this is automatic routing discovery, meaning every packet is sent is what we call explorer frames. Basically, it screams and everybody else also screams. So tweet, 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 every node screams. Now all the data is sent to the router, central location. Central location builds a map. It does it automatically. Based on that map, it figures out which is the most optimum data packet route. Based on that, it configures the network. So, and that itself is just a network discovery. That's not WoW. What WoW is, basically, this will be periodically updated. Sometimes it could be once a day. So if you have a sensor down, it will not cause you more than 1 day of downtime. So it can automatically heal. Most of the time, you will never notice it. That's how good these things can be if done and set up perfectly. So you can have like one node going down, the data packets will literally go to another node until it reaches this point. And it's quite good actually. And most of the time, all problems can be solved with just like, if you have a problem, update it manually. So periodically, it could be like, last night or something like that. You may be like, okay, let's just manually refresh it, solve the problem. So topology is quite smart. Now, what about products? This is a protocol. So protocols are useless if you do not have products for it. So Z-Wave has a lot of experience in this market, and because of that certification process, it is expensive. Let's be very clear that Z-Wave Alliance certification, it is expensive. But, sorry about that. But because of the increasing competition, they have open sourced a lot of data by 2020. So I cannot specifically specify how much is open source, how much is still closed source, but far more open. They are far more open compared to their previous counterpart. So Z-Wave Alliance should see price coming similar to the non-systems. Basically, the price premium that we used to pay for going instead of Zigbee to Z-Wave, that should come down in price. Not right now, but it should happen in 2-3 days until other chip fabricators starts to mass produce them. So that should happen. Let that be very clear. That should happen. I cannot guarantee it will happen or when will it happen. So it's a long sort of process. However, they were Z-Wave in early days from 2005 to 2015, there was a sweet spot for them that they were the only thing that people were trusting. They were only thing hotels were using, schools, hospitals, things of that nature. They were like robust, and that was the wisdom they had. It's like, dude, unless we verify it, money is not that much of an object if people cannot trust it. So, and it paid off. However, there is another backwards entry into this, meaning imagine Z-Wave. How the heck Z-Wave started to reach this point? Basically Zigbee. Because Zigbee started to sell a lot more, exponentially lot more. So it literally incentivized a scenario where it's like, hey, we are selling 10,000 of these devices. Wouldn't it be wise to just invest some amount of money to make sure that it actually works with everything else? And again, companies started to do that. Day 1, not that great. Day 500, it was good. Day 1000, it was like, damn. So competition. That's why they have opened it. It was like smooth sailing to like, okay, now we have a competition, to like, wait a minute, competition is smooth. It's exactly like how iPhone in early days were like very smooth. It took till Android 4 where the smoothness was starting to match. By Android 6 it was like, whoa, how the heck both can be so smooth? And then we started to reach a point where it's like 120 hertz came and went in Android. Then Apple is like, we will reach it. So there it happened. So for few years in the smart home ecosystem, Z-Wave was done. Like Z-Wave was like, that's the thing that you have to buy in order to get things going. But that era so far has passed. And again, it does make sense. Like, why would you open it if it was a still cash cow? It's not. So they opened it. So what about competitions here? This is where it gets odd. The market is way too flooded. Generally, this does not happen. You will only have one or two things. You will not have hundreds of things. So you will not have Zigbee, Wi-Fi, Halo, Z-Wave, Thread, Matter, and there are a few more, but these are the big ones. So the radio communication standards cannot be so many. Like, you cannot. Like, fundamentally, even in 5G, you may be like, oh, don't they have bandwidth? That's because of the law, and the radio generally does not change that much. It's just the frequency. Of course, there is some up band and down band. Then it goes to basically 4G bands. Nothing major. Here it's like Zigbee is different, Z-Wave is different, Wi-Fi Halo is different. Now, best one on a technical standard is Wi-Fi Halo, because it has the same frequency as Z-Wave, lower than 1 gigahertz. So it has range, it has mesh network, and this has higher throughput than all of these things combined. So it can actually do IoT security cam. That's how much throughput this puppy has. So my personal favorite is this. Bluetooth is also there, and normal Wi-Fi is also there. So many light bulbs are there. Many companies just gave up on all this hassle. They're like, dude, just Wi-Fi, done. So Z-Wave, Threads, Zigbee, Matter, Wi-Fi, Bluetooth, Wi-Fi, Halo, Threads. Wi-Fi Halo has good adoption in industrial environment, very poor adoption in home scenario. So market has not chosen a winner yet. We are not in a point where it's like, this is it, this is how we're gonna go. So basically, there used to be a lot of operating system. Then Microsoft and Apple became the thing. We have not that the thing happened here, not yet. So market is very messy. And as of now, because of the entry of these two players, things are becoming a bit messy. And yeah, these two are like very conglomerated, so to say. So Z-Wave's future is very shaky. Actually, many people started to sound alarm the moment they open sourced it. So again, because these smart home devices do not last very long, so you do not have to worry too much about it. Even if you buy today something, let's just say you bought Z-Waves and it was like done. Again, the devices will work for a few years, and when you have to replace it, then buy whatever is popular at that time. If Thread is popular, buy Thread. If Zigbee is popular, buy Zigbee. If Wi-Fi Halo makes a comeback, buy Wi-Fi Halo. So market is very messy at this point in time, like way too messy than it should be. So this was my presentation on Z-Wave. Hopefully you have liked it, learned from it. In that case, please hit the like button, share it amongst your friends. That will help me a lot. If you didn't like it, didn't enjoy it, I urge you to press dislike, press it twice to show me extra disappointment. Please leave a comment because I do try to reply to all of them. Subscribe, press the bell icon if you're free, and as always, thanks for watching.